We're going to be taking a look at question 19 from the 2022 Math Methods External Exam, Paper 1. Now, you would have noticed on the channel I've been splitting up all the questions into individual videos. That way I can go into a bit more depth on each question, and if you only struggle with a certain question, you can go watch that certain video. If you're interested in an external exam bundle pack for Math Methods, the link is in the description below, so go get your download quick. If you're interested in the full exam, link is in the description below, as well as the playlist. But let's get straight into question 19, because this one is one of the hardest ones I've ever seen. But let's just see how we can break it down and make it a lot easier than what it makes it out to be. Okay. So first of all, when you're met with this question, it's overwhelming at first. However, what we've got to understand is what they've given us here. Okay. Two triangles are said to be familiar if their corresponding angles are congruent and their corresponding sides are in proportion. Example, triangle UVW is similar to XYZ. Then they give us this information here. This is information they are providing us in the question because we may not remember what similar triangles are. So for example, if we have a triangle like this, let's just make two little triangles. One will make significantly smaller. So for example, if this triangle is 15 and actually let's change that. Say this is 3, and let's say this is 2, and let's say that's 30 degrees. Let's say that's 30 degrees, that's 15, and that's 10. These two triangles would be similar because there's a factor of 5 between each of the sides and they have the same angle. That is basically what they're trying to say here in terms of the ratio. So here, that symbol stands for triangle UVW, triangle XYZ. And here they've got the ratios of the sides there. We may need this when we're doing the actual question. It is just extra information they are providing us in case you don't remember things about similar triangles, because in this syllabus here, last time we learned about similar triangles would have been maybe 2 years ago, etc. Okay, or very like early year 11. Okay, let's go into the question now. Two parallel walls A, B, and C, D, where the north ends are A and C respectively, are joined by a fence from B to C. So first of all, let's draw this picture. So two parallel walls means pretty much we can say they're in the exact same direction and they would never touch. Now here they said the north ends are A and C respectively. So here we're going to put A here, and here we're going to put C here. So that means B must be down here, and D must be down here because they said two walls parallel. Okay, that's important, just drawing that part of the picture. Okay. The wall AB is 20 meters long. So this wall here is 20 meters. And here the angle ABC. Now here, straight away, they've already established are joined by a fence from B to C. So there's a fence that exists right here. So we can draw a line like that. Now, if you understand your geometry, which you should, you would know that those angles are going to be exactly the same because they're two parallel lines and they've got that line going between them. It's the Z rule. So when they say the angle ABC is 30 degrees, ABC, they're talking about this angle here. We actually indirectly already know that angle would also be 30 degrees, but I'm not going to put that on the picture just yet. Okay. The fence BC is 10 meters long. Okay, great. So we know this one here is 10 meters. Okay. Now they said a new fence is being built from A to a point P, which is somewhere along CD. Okay, the new fence AP will cross the original fence BC at O. So what that pretty much means is I'm just going to draw a point P here. P could be anywhere along this line here, but there is a fence going from A to P, and it crosses at this point here O. That's all they're saying at the moment. Okay. Let O to B be X meters. So B to C is 10 meters, but O, what did they say here? O to B, so this distance here is X. Great. Determine the values of X that minimizes the total area enclosed by triangle OBA, which is this triangle here, and triangle OCP, which is this triangle here. Verify the total area is a minimum. Okay, great. We have now drawn the pictures. Now, hopefully you can see why they provided similar triangles here, because we know those angles are the same using the Z rule, which means this triangle and that triangle are most likely going to be similar, okay? Which is why we probably need this information up here. Now, other things as well we need to establish. We know, if I can get my highlighter, we know that this line here is 10 meters, and we know this little section here is x, which means up here, this distance here would be 10 minus x, because the whole distance is 10, therefore x plus 10 minus x has to add up to 10 there, okay? Now, this is all we have at the moment. Now, what we also have to establish is a formula to work at the area of a triangle. Now, in methods, you would have been taught this formula. Area of a triangle is a half BC sine A, when a triangle looks like this, where you have BC and angle A there. We're most likely going to use this at some point. Now, first of all, we need to establish which sides are similar to this triangle here. So, what we need is basically, using this formula here, we need a point, and we need two sides, the B and C, and the angle here to work out the area, so angle A. We already have that information just here. We have 20, we have 30, and we have X. So the first triangle is already sorted. It's the second triangle which we need to work out a bit more information about. Now, we already know a lot of the information. We know that that is a side. We know 30. We just need to work out what this side is here. That is where the similar triangles come in. So, what we have to do is visualize. Now, because that angle is the same as that angle, if you were to rotate this triangle, that means this side here has to be similar to this side here, which indirectly means that this side here has to be similar to this side here. So let's put that into words here, okay? So because they're similar triangles, we've got, quote unquote, if we're talking about side lengths here, the ratios, so we've got B to O, so B to O over O to C, so those side lengths have to be the same as B to A over C to P, because they're similar triangles. So I'm using information from here about the ratios of the sides here. I'm not using that formula directly, but I'm using ideas from it. So that's why this question is super hard, because there's a lot going on and you need to apply a lot of knowledge. There's no memorization in this question at all. Okay, now that we've got that, let's just fill in the information, okay? So B to O we know is X, so we have X. O to C we know is 10 minus X. B to A we know is 20. And here we have no idea what C to P is, but that's what we're trying to work out. Now you might be wondering, how can we work it out if X is already there? We want to work out what it is in terms of X, because remember the question is a minimizing question, meaning we still want a variable X present. So here our goal is to work out what C to P is in terms of X. That way we can establish a formula to work out the area of the triangles pretty much. So what we're going to do is we're going to flip both equations upside down. So 10 minus X over X is equal to CP over 20. We are going to multiply both sides by 20. So you have 20, 10 minus X over X equals CP. Now I'm going to try and sort that out a little bit, so multiply that out. So you have 200 minus 20x over x. That is going to be the side length of CP. So 200 minus 20x over x. And of course you could simplify that a bit more, but that's all you need at the moment. Alright, I'm going to get rid of this information now. Okay, so let's work it out. So let's just call this triangle ABO. What do they say? Oh, they said OBA. Okay, so triangle OBA. The area of it is a half times by x times by 20 sine of 30 degrees. Triangle, what did they say? OCP So I'm just trying to label it how they've labeled it here. Area of that one is a half times 10 minus x times by that thing we just worked out, which I'm going to run out of room for. 200 minus 20x over x sine of 30 degrees. Alright, that's the hard part done. So, now that we've got that information, let's move it down to another page because I'm going to run out of room up there. Okay, so now that we've got that information, remember the goal is to minimize the area. So we need to create an area function that depends on x, meaning you just add these two together. But before we do that, let's simplify things here. Now, realistically, I probably shouldn't have multiplied out that 20. I'm going to factor that out again. So I'm going to write that as, just scroll up, see what I had there before. Yeah, 20 times by 10 minus x. Because a half times by 20 is going to give you 10. So, and then here it's the same thing. So the sum of both triangles, so the area of both triangles is a half times 20 is 10, so it's 10x sine of 30 degrees plus, now here there are two 10 minus x's. So you have 10 minus x squared over x, and you've got a 10 out the front there. Then you've got sine of 30 degrees. Okay. Now you might be wondering, why haven't I simplified anything else? Because there's one more thing you can do. We have to work out what sine of 30 degrees is without a calculator. That is where these triangles come in. You should know these triangles heading into your external exam. Now I'm just going to draw the one here, but there is another one, your 45 triangle. So here, sine of 30 degrees, you go to 30 degrees, and you go, alright, what is your opposite, and what is your hypotenuse? So sine of 30 is a half. So both of these guys here turn into a half. 10 times a half is 5, so area is 5x, plus a half times by 10, which is another 5 there. So 5, 10 minus x all squared over x. There you go. That is not too bad now. Now we have to minimize this, which means we have to work out when the rate of change is equal to 0. And we also have to prove it's a minimum, which means you have to show that the second derivative is positive at that stationary point. I know. Okay, so let's get on with it though. My advice, move the x up there, and we can do it as a product rule instead. So area is 5x plus 5x negative 1, 10 minus x all squared. Now we differentiate this here. So dA dx, differential of 5x turns into 5. Then we're going to do the product rule here. So I'm going to differentiate this one first. So bring the negative 1 down the front. So negative 5x negative 2. Leave this guy here. Then I'm going to add it. 5x negative 1. Then I'm going to multiply it. Bring the 2 down the front. So 2, 10 minus x to the power of 1 times by negative 1. There you go. Now, I would try and simplify things as much as possible. However, we are going to have to differentiate again. So here. Now the thing is, if I make a mistake, then we're kind of screwed. But that's okay. I'll just rewind the video and just edit it. Hopefully, if I remember. Okay, negative. Okay. Also, if you have any questions at all during this video, leave something in the comments and I'll try my best to answer it. Alright, 5 times 2 times negative 1 is negative 10, and I'll just go x negative 1, and then 10 minus x. Okay, now let's make another page, because we're going to need it. I'll probably skim over this working just before I end the video as well. This is why I like doing the things in separate videos, because I can go into this much depth on each question. I don't think I've actually done this one on the channel just yet, as I'm recording it though. Okay. So you would obviously set that equal to 0 and solve for it. But here, let's also differentiate it as well, because we're going to need the second derivative at some point. Now what I would do is I would multiply that guy out to make it a bit easier. So dA dx equals 5 minus 5x negative 2, 10 minus x squared, minus 100x negative 1, plus 10. And that's it, because the x to the negative 1 times by x cancels out completely, and you're left with nothing there. Or technically an x divided by an x, but that's okay. Alright, now, we should probably differentiate this guy now. So the second derivative, the 5 turns into 0, so 0. Now we're going to use product rule here. So I'll differentiate the first bit here. So it's going to be positive 10x negative 3. 10 minus x squared plus negative 5x negative 2 times by 2, 10 minus x power of 1. Then we differentiate this guy here, so it's going to be positive 100x negative 2, and that's it. Okay, cool. Now that we've got the second derivative, assuming we've done everything right. Now, we have to solve for the first derivative when it's set equal to 0. So what I'm going to do is rub this guy out. Now the annoying thing is this entire question is calculator free as well. So I understand why it's worth 7 marks. Okay. So you have 0 equals 5 minus 5x negative 2. 10 minus x squared. Now here I'm going to rewrite that guy as positive, oh no, not positive, negative 100 over x plus 10. So here, I've got to solve for x. So ideally what you want to do is you want to start expanding things and start cancelling things out properly. Now what I would notice here is you can combine the 5 and the 10. I would just move it to the other side perhaps here, or just leave it the same. So I'll go 15. I'm going to write this again, but it'll be negative, so negative 5 times by this, all squared, over x squared, minus 100 over x. Now, ideally here, I would probably see if we could multiply everything by x squared to cancel out the stuff on the bottom. Because if you multiply everything by x squared, it just depends what you're going to have happening on the top as well. So I would multiply everything by x squared. So you'll get 0, 15x squared, minus 5 times 10 minus x all squared, minus 100x. And you're probably wondering why I did that. To make it a little bit easier, hopefully, in the long run. Now I'm going to go down, maybe get another page of working here going. This is going to be a long video. That's okay though. Alright, let's go down here. Okay. So here I would expand that. So you have 0, 15x squared minus 10. Expanding that is multiplying this guy by itself. So you're going to get 100 because 10 times 10, so 100. Then you're going to have 10 times by negative x, and you're going to have that twice. So you can have negative 20x plus x squared. So here we've got this, 100 minus 20x plus x squared minus 100x. Multiply the negative 5 out to here. So you have, so negative 5 times 100 is negative 500. Negative 5 times negative 20 is positive 100x. Then you're going to have minus 5x squared. And then here, minus 100x. Hopefully you can see what I can see. Those guys cancelling out. And you can also see these guys adding together. So 0 equals 10x squared minus 500. Move the 500 to the other side, gives you 10x squared. Then what you're going to do is divide both sides by 10. So here you have 500 over 10, which gives you x squared. So this is going to give you 50, which is x squared. So x is plus or minus the square root of 50. Now realistically, x has to be a positive value. So here we're just taking the square root of 50. Now, we still have to work out Determine the value of x that minimizes the enclosed area and verify this is the total area is a minimum. So you don't have to calculate the area, you have to find the value of x, which is what we've done. But now we've got to show it's a minimum. So you have to chuck that value into the second derivative, which we worked out just here before. And to determine if it's a minimum, it has to give you a positive result. Okay, now the copying and pasting is not going to work. There we go. Okay. Alright, let's go to a new page though. It's going to be like 20 minutes or something, or close to it. Alright, so here we want to show when x is the square root of 50, that the second derivative is positive, okay, to verify it's a minimum, because it's going from a negative gradient to a positive gradient, okay, which is an overall positive rate of change. Here I would try and tidy things up, because you don't need to compute the exact number necessarily here. You just have to show it's positive. So rewriting this guy here, I would write that as 10 minus x all squared over 10x cubed. Here I would have negative 10, and then I'd move the x squared to the bottom, and then I go plus 100 over x squared. Now here's a good thing, because it's the square root of 50, it's going to be okay-ish to work out. Okay, so wherever the x is, we're going to chuck in the square root of 50. So chucking it in, we're going to get 10 minus the square root of 50 all squared over 10 square root of 50 all cubed minus 10 minus the square root of 50 over the square root of 50 all squared plus 100 over square root of 50 all squared. Okay, so let's try and work some stuff out here. Now, what we've got to look out for here is whatever this number is, it's going to be positive because it's getting squared. So this is a positive result. This is going to be a maybe, oh actually, so the square root of 25 is 5. The square root of 36 is 6. The square root of 49 is 7. So here, the square root of 50 is most likely going to be less than 10. So what that means is, this result here will be positive, multiplied by a negative number. So this result will be negative here, but we've got to work out what is going to be bigger though. So this is where the arguments start coming involved. What I would do here, I know that result's going to be positive, however we're going to need it in a comparison just here. Okay. Again, this is assuming we've done everything correctly. The square and the square root cancel out, so this just turns into 50 on the bottom for both terms here. So here, that number turns into 2. This number here, we'll just write it as negative 100 plus 10 root 50. Now, here's the thing, we want to work out if this number is positive or negative. Now, we know this result is positive, okay? If we can work out what this is, which it's probably going to be negative realistically here, but we just have to double check, okay? So, in this case here, what we might do is go to a new page as well. I like doing all the videos in one take so you can see realistically how long it would take as well. This is a long question though. Now mind you, it is longer than how anyone would sit it because I am explaining each step here. But it's always good to see it from a different perspective anyway. Now that did not copy and paste that well. Okay. So what we'll do here, let's try and work out what this would be. We'll try and put them all over us 50. So we'll have this bit here. So we'll have 10 minus root 50 squared over 10. And then a square root is a power of a half. So you have 50 to the power of 3 over 2. And we'll work that out very shortly. Minus 100 plus 10 root 50 over 50. And then here you'll have plus, I'm just going to leave it as 100 over 50, and you'll see why very shortly, just because everything will be over one denominator. Now, that negative, does that apply to, what have we done here? Oh, that's going to work out quite nicely. Okay, so here, that negative is applying to that guy there. So when I apply the negative 10 here to both of those guys there, that turned into positive, that turned into negative. So this negative is only applying to the 100 here. So you have an addition here. Now the reason why that's good for us is because this and that will cancel out very nicely. Okay. So here, if you put them over one denominator, you would only have 10 root 50 over 50 there. And then you have plus, and this bit here we know is positive. So again, we don't have to really do much here because we know that this is greater than 0. And we also know this term here is greater than 0 because the top is positive, the bottom is positive, therefore the whole thing has to be positive. Which means when you chuck in x equals, so x equals the square root of 50, your second derivative is greater than 0, therefore it's a minimum. Wow, that's a tough one. Alright, is that a hard question? No, not really. I'm kidding, it is a very hard question, okay? However, they gave you this information because without this information, everyone would have been destroyed with this question. Okay. If you have questions about this one here, leave something in the comments and I'll try my best to answer it. If you want a a methods external exam bundle pack, the link is in the description below. And very soon there will be a bundle pack where you can get a physics, a chemistry, a methods, and a specialist external bundle pack. But the discount for that one will only be given out to 10 users and they'll be coming very shortly, so stay tuned for that. And if you want the full exam video, the link is in the description below and the whole playlist as well. But otherwise, I'll see you in the next video.